Hello, I'm Lance Holtman, and I'm presenting my ECT295L project. It's our senior project, one of the last courses I'll take here. I thoroughly enjoyed the project myself. We were assigned the task of building a digital compass. I've inserted mine into a case just to keep the components safe while I tested it and modified the program code, which actually required several test runs for me. The compass module is actually an input device that senses the direction based on which way a magnet inside is pointing. It sets an input value to the integrated circuit, the PIC 16F72, I believe what we used. The port A would sense the direction that the compass module is pointing, and it would set that value as the direction within the program. Then, based on which direction, it would actually define the binary values to output to ports B and C for the first and second letters of the alphanumeric display to show. The project itself is fairly simple. We were given the compass, that program code that shows north, east, south, and west, and we were told to modify that so that it would display arrows. I've modified mine to display the arrows. A quick demonstration there. I will include a full demonstration later on in the video. It's a little bit easier to see. Right here we've got the ability to turn it on with a jumper. The method I chose was the on-off switch. I just happen to have one handy, and like I say, this temporary solution to put it in the box while I tested it and worked on it, and it actually worked out nice and permanent. It's pretty sturdy in there. The only thing that'll move around is the battery. As far as that, it's pretty straightforward, and the project went pretty well for me. I'm going to demonstrate the compass displaying the directions, and then show you the modification. In this video, I've removed external sources of light to better illustrate the alphanumeric display. It wasn't showing up well on the camera before that. As you can see now, from the orientation of the sensor and the direction displayed, it's pointing north. And the compass will successfully display all of the directions as we turn it around. All the way back to north. For the modification, we were required to connect pin 15, or pin 14, pin 13, and pin 11 on the PIC 16F72 to the dual alphanumeric display to pin 15, 14, and number 4. The connection between 14 and number 4 is actually shown with this red wire here. The yellow wires are connecting between 14 and 13 to actually 15 and 14 on the dual alphanumeric display, as you can see. The purpose of the modification was to allow the unlit segments of the dual alphanumeric display to be lit when the proper outputs were set. And just to quickly show, the modification was successful. These ports that are lit right at this moment are actually some of the ones that were not connected in the original kit schematic. I'll demonstrate the modifications display arrows with another video where you can more clearly see the display itself. Again, I've turned off the lights in this video to better illustrate the dual alphanumeric display. So again, I'm starting with the compass pointing north. The arrows are pointing upwards. And if I turn the compass here, you notice that the arrow will point north, regardless of which direction it is facing. On the original circuit that I was building, the first compass kit that I had purchased, it looks like I may have actually gotten a bad voltage regulator. The component was heating up, and I actually went to lift the circuit up whenever I realized it wouldn't power on. I went to lift it up and I burned my hand on the voltage regulator. Dropped the circuit, and I took a look at it just, after I took the jumper off. I took a look at it just to see if there may be any solder bridges or something out of place that could be easily fixed. I didn't see any obvious problems with the circuit. I looked at each of the components in turn and noticed that the SIP network was soldered in backwards. I went ahead and tried to remove the SIP network without damaging it, which led me to damage the printed circuit board. Actually, I broke loose one of the leads that goes to a pin, and I don't think that would be reparable. I went ahead and ordered another kit just to make sure I wouldn't fall behind on the project. I looked online, first of all, for a SIP network that would replace the one that I was trying to remove. I was able to find one, but the lady said that it would be probably a week and a half out, and the kit for the compass would not take that long to get here. So I went ahead and reordered just to be safe. I later received the SIP network that the woman decided to send me, and when I spoke to her on the phone, she sent me the SIP network, and just out of curiosity, I soldered it in, checked other parts, and whenever I powered up the circuit, the voltage regulator burned my hand again, even with the SIP network in properly. And so it looks like I may have gotten a faulty component in the first kit, and I was not able to track it down right away because of an obvious mistake that I made myself. With the second kit, construction went very smoothly, and I came out with a very neat looking circuit. There's not burns on the circuit board. The solder work is very clean, and so very good result out of the second kit. One point where I did have to troubleshoot, I had followed a picture that I found on the discussion. I thought it might be an easy place to start. To solder the leads from the integrated circuit to the dual alphanumeric display. The picture was actually made wrong, and so it was illustrating the wrong pins to connect the jumpers. So one thing I noticed whenever I turned the circuit on, that one segment of the display was staying lit no matter what. This led me to only one conclusion, and that's that I've soldered in a connection between something that has a live output voltage to one segment of the display, and on closer inspection I noticed that the pin configurations of the jumpers weren't correct, and I needed to move them all. Basically a mirror version of what I did, and so I did. This resolved the issue, and the modification actually went really well. For future improvements, honestly I'd like to put it in a better case that would probably be more shock resistant. If I dropped it in the wooden box that I have it in now, it's likely that the components would go flying all over the ground. That's not a permanent solution, so I would like to get it encased in something more permanent. I'd actually like to add an input button into port A that would allow me to set a variable in order to control which program or what it's displaying as far as arrows or directions. I'd like to be able to push a button and switch it from arrows to directions, and I think that'd be an interesting addition to the compass hardware and software. Really, this would just require mapping an input to port A, setting the variable. You would have to, of course, set the proper bits to make that certain area of port A an input according to the data sheet for the PIC16F72. Would be an interesting addition. So I'd like to get it encased in something more permanent, and I'd like to include that new function. We were given the components to build a compass. we were given the task of modifying that the compass that we built, and I believe that I completed construction fairly successfully, completed modifications in working order. This project was actually very enjoyable. Even when I was behind, I still looked forward to the end result. I feel like I did a fairly good job of sticking to the schedule that I'd set for myself, even with the setbacks that I suffered. And I'd recommend this class, this project to anyone who's had an interest in electronics. I enjoyed the course. Thank you, Professor Nixad. I appreciate it a lot. Thanks.